what do we need to know about the disk analysis here? The disk analysis is, as you know, probably there's a bunch of artifacts that we're going to be looking at that are important to us. And a few of those I've listed here because they will be important today. If you want to know more, obviously, there's this Practical in Forensics course that covers everything. You have the cheat sheet that has covered way more than just a few artifacts that are on here. But the ones that I'm interested in our particular cases, I have Alice downloading a file from a browser, storing it, executing it. There's persistence and things along those lines. So obviously, a few locations are interesting. It is going to be the registry files. There's a user class and an NT-user registry hive that is specific to each user on a Windows system. Then we have the system hive and the software hive that is all kinds of system-specific configuration and application kind of configuration information on a Windows system. So very important to look into those. Lots of good stuff we can extract from there. Then other than that, obviously browser artifacts, if you can parse browser artifacts, will be interesting. And then files, right? Did any files end up on our system? Which ones? Do we have data exfiltration? Something we looked at last time. We will be doing so today as well. Well, that will be in the NTFS related artifacts, right? We have MFT, which is the master file table that stores information about any files and folder that's created, accessed, or deleted on a file on our Windows system. And then, of course, everything that is captured in event logs. Not everything is captured in event logs technically. So we only get what we can see, right? Event logs are only capturing the specific things that they're concerned about. There's a lot of things that fly under the radar that would not be detected in event logs otherwise, especially, as you know, with Sysmon. You see a lot more things already if you just go with the regular event logs. We've mostly covered that with Splunk in the previous session, so we won't have time to manually go through these. So maybe do more manual analysis around the registry hives and the file system metadata as it pertains to our case. Now, how do we go about it? We have the cheat sheet, and then we want to capture information, right? The first thing I would do when I start an investigation, even with memory, but now in the disk especially, extracting information about the system itself, right? I want to know what's the operating system type, when was it last accessed, shut down, what's the different, just some metadata around the system so that I can actually clearly say, hey, this is actually a system I'm expecting to look at. I've had many times somebody hand me the wrong system that I was not expecting, and I started looking into it, and then turns out it was not the right system that I was actually interested in. So first of all, clarification of what are we looking at, and then we can dive deeper into evidence of execution, persistence, things along those lines. So for that, let me show you just real quick. We'll capture information. We need to capture information somewhere, right? And typically this is what it would start with, right? I would want to look into the system first of all to get this kind of information about what's the host name, the operating system type, what's the IP address, the owner of the systems, especially time zone, and also some settings that might already be interesting, such as was real-time monitoring, such as Defender. Was it disabled? Was it enabled? Oftentimes it's disabled at the time of when we capture it. So some high-level information before diving deeper. Now, let me find my Windows system here. So now, before we go in the Linux system, now we're jumping quickly over to our Windows system because a lot of tools are based on Windows that we are working with here. And here, first of all, you can see the cheat sheet. Now there's some information on how you can extract data from disk and memory. But really what we're interested in here is now the registry hives and the locations, such as these here. Those are mostly stored in system32 and config. And then once we have extracted those, we can then look into the information I was talking about earlier, right? Information about the system. So we can see the system hive has a location that is called computer name that should tell us more information about the computer name. The software hive has information about, which is called current version, which shows us the Windows version of this particular system. And here's where we can find time zone information in the system hive. Here's where we can find network information, the information about each network interface in the system hive. So this is what this cheat sheet is, basically helping us with. I can't remember those locations off the top of my head, so no point in trying to memorize everything. Now, there's different ways of how we can parse this out, right? We cannot look into, for example, registry hives just by opening them. We need to parse it. We need a parser. Different tools out there. Eric Zimmerman tools are great, but there's also another tool called RegRipper, which is out there. So one of my favorite tools, RegRipper, you basically just point it to a registry hive and an output file, and it would apply all the plugins that it is aware of and dump those into a text file. So it would apply a plugin, for example, for parsing the computer name. It would apply a plugin for extracting the Windows version, right? So anything that's in the registry hive that is not known by a plugin that we are applying will not be extracted. So don't say, you can't say it didn't exist in registry. It just did not show based on the techniques and methodologies that we were using. We don't know what we don't know, right? There's other ways maybe to look for this, but overall, RegRipper is really good. And so one thing you can do with RegRipper is, for example, if you're just looking for a specific particular plugin, so we can do, let me go to my commands here real quick, my cheat sheet, so I'm not messing things up. You can run RegRipper, and then we just point it to our cases files, and then point it to the registry hive. And in my case, that's in a triage collection that we've, basically the ones that we've provided to you as well. In system32 config, right, there is software. And then we need to say a plugin that we want to apply against the software hive. I know off the top of my head, or been doing this beforehand. So there's a plugin called Windows version, WinVer. And if we do that, I guess I need a -R to point to the file. It now just extracted information about this particular Windows version based on the disk information, on the registry key, which is on the disk. So this is the disk that we gotten. We have Windows Server 2019. We have the installation time and the minor and major versions. So this is great information, but if we apply, we can basically apply all plugins against this and then just look at the output and the text format as well. This is what we're going to be doing. I've applied this RegRipper against the software hive, against the system hive, and against user class and NT user hives. And when you open those up, you can see that here, there's RegRipper NT user for Alice, RegRipper user class for Alice, RegRipper system for the system itself, and then RegRipper for software. So let us start with the structured kind of methodology as discussed before. I am looking into what's the computer name. The computer name is under system computer name. So I would just go in here and say, hey, is there a computer name in the system hive? And there it is. So we can see this comp name plugin was applied, and we can see the computer name is client2. This already confirms what we are hoping for, that we are looking at system name for client2. Then I will continue, right? You get the idea, right? We already looked into Windows version. We can also look into network. So system and then interfaces. Let me see if we can find in the system interfaces. So there's a plugin called NIC2, and we have an adapter with this GUID. And this adapter had enabled DHCP, and here is the IP address. So we have the DHCP IP address of the system. So now we can confirm its own IP address. We can also confirm the name server, which is our domain controller, and we can confirm the DHCP server, which is the gateway that was configured. So now we know the system we're looking at, right? So that's some of the meta information that I would always first go with. Now, after filling this out, as you have seen before, we should get to something like this, right? This is the overview of the system, and now we can dive deeper. If we want to know, for example, what this user did, if you want to know what was executed, if you want to know about files, there's a few locations. User assist is a great artifact to see technically what a user was accessing or executing. So user assist is located in ntuser.dat. And then there's a GUID. And there's user assist contains a couple locations. There's a GUID for a list of applications or other objects that have been accessed, and also a list of shortcuts, links used to start a program. So clearly, user assist might be an interesting point to get started with if you're looking for Alice, what Alice was doing. So, or a user that logged in as Alice. So now we're looking in user.dat, ntuser.dat, and now we can use user assist. And here's the plugin that was run for user assist. And then if we go back, I can already tell you right now, this is actually the program execution GUID I was talking about earlier. And then we can already see some of the information, some of the programs that might have been executed. Windows on this date, this is important too, right? We are interested in 2024. And there is Explorer, obviously, that was executed. There is FTK imager that was executed from a file share. There's MSHDA that was executed. Clearly, that will go into my notes for sure, because that's the malicious MSHDA was used to execute the HDA file. There was also Notepad executed on that day, 8:30. And then we also have Wireshark that was executed. Obviously, that's FTK image, and Wireshark was for me to capture some of the network traffic and information. We also have CMD.exe that executed. We only have one entry. Actually, it says 4 entries right here. That's what I mean. We have one entry here, but it was executed like 4 times here. And the last time was here. You see the last timestamp. So this is a really good evidence of something that executed. Then we have the link files that are captured in this GUID. And then if we go by this date again, you can see Firefox was open through a link file, Wireshark as well. A few things that just the user did while they were logged down there. So user assist clearly has a few artifacts. I would now capture that, the date. I will capture the artifact location. I will capture the payload here in a timeline that allows me then to understand what happened, when, where, and how. So this is the first artifact. Now, let me see if we have a few more that I want to look into. Of course, software. We can also look into user class. First of all, user class for Alice itself. Anyone familiar with shellbacks? If you're familiar with shellbacks, hands raised. We have entries in here. Bunch of hands, yep. So here we can see shellbacks was parsed out from user class.dat. So this basically shows files or locations that might have been opened by the user from the Explorer, from the Windows Explorer. And that's already interesting because we can see MRU, so most recently used time, so when most recently this location was open, and then we can see our date, 24/8/30. So there is files, the file backup folder was accessed from a file share. That's in order to put the files on the system. That's what I did. But basically, I can see files backup folder was accessed at this particular time through a Windows Explorer session. Then we can also see some more. We were within that files backup. We actually looked into projects, into admin, into accounting folders. And then you see if there's a few more interesting things here. On the bottom, we can also see, as it relates to the timestamp here, the downloads folder was opened at this particular time. And if we suspect an incident that triggered around this time, could have been Alice clicking on something that it downloaded, right? And which is obviously the case here. So this is evidence of that. All these things, there might be more, as good information that we could extract and put into our reporting, into our timeline as well. I'll show you the timeline in a little bit after this, after going through some of the artifacts. Now, 1 or 2 more other things, for example, software has a bunch of interesting stuff around the system itself. Windows version we've already had, but there's another one. For persistence, we could, for example, look into tasks. Tasks are also stored in the software hive, scheduled tasks. So if we just go through the task cache, there's tasks which includes all of them. Task cache here basically includes this one that is actually relevant to us because this is the timestamp of what we're interested in. NPCap watchdog, that sounds a lot like Wireshark. And then updater, and we've seen before a malicious task that was created with, it's called updater, and then when it was created. And this is right in there. So right on the money, this is exactly what we're looking for. We have evidence of a task that was created that we can now look into. We already have done so last time, but still, this is evidence of the task that would go in my timeline as well. And then finally, to use the system, the system registry hive as well. So we've looked into network interfaces. There's also, let's see if we can find background activity moderator. That's evidence of execution. So within system, we can also look into areas such as the background activity moderator that is keeping track of applications that were executed and by user. So here we can have here we see a SID. This is for Alice. This is the SID for a domain admin, but here we have Alice. And then we can also see there was this is kind of the time frame that we are looking at here. We have an Explorer, we have NPCap, we have Firefox. So we can see that this user executed Firefox based on this entry here. That was used to download the malware accidentally by Alice, but still. So, lots of great locations, and this is all contained, step by step in these. So for example, here, in this cheat sheet, system, background moderator, system mcache, prefetch, which is mostly not on Windows servers, but on clients, link files. For persistence, we can look into auto runs, and we can look into run locations, scheduled tasks, Windows services, things along those lines. Could cover them all. That's another topic for the course, for on-demand course. We don't have enough time, but just saying, I've pulled together so much information just by from the registry. We could also look into NTFS data now, and we could parse the MFT, and we could parse the USN journal, which captures file operations on a system. And for that, I've already done so. I've used Eric Zimmerman tools to basically parse out the MFT and to parse out the USN journal. And then, for that, the entries are basically MFT entries. So you have entry numbers and so on. And then from there, you have the parent path, the file name. And if you're familiar, I think we've actually covered NTFS and MFT beforehand. If you remember that, we have timestamps. So each MFT record has a number of timestamps associated with it in different types of attributes. We have the standard attributes, in which has created timestamps, modified timestamps, record changed access. So we could now sort them by created. We could see other files that might have been created at this around the same time frame that the file that we are looking at was created. And that's sometimes the only way how I find out about files that I might be interested in that I didn't even know about. Sometimes you need to sort by modified. Obviously, that makes a difference, right? Or accessed. So there's different ways of how you could actually go through a timeline in an MFT, which has hundreds of thousands of entries. But to limit it down, we already had an alert that update.exe.hda was downloaded. And we could just look for that for now. And then from there, we can see we have a hit. We have in Alice downloads, we have update.exe.hda. We even have the MF3 entry here, and we have HDA zone identifier, covered it last time. There's also an alternate data stream that also stores the zone identification, the zone information, which is basically the location where it was downloaded from. We can see the file size, when it was created, when it was modified, and when the record was last changed, and when it was accessed. So all these 4 timestamps I would put into my timeline, because creation doesn't mean modification, right? So we can, in this case, kind of see that it actually is the same, but usually it might actually be accessed, modified at a later time again. So we need all of these timestamps in our timeline. And for the zone identifier, we even have a parser in the Eric Zimmerman tools that can actually get us information on where this actually was downloaded from, which is the windowsupdate.com URL. Obviously needs to go in our timeline. Now, we also have one file, before we forget, we're also looking for a data exfiltration, right? There was one file that we discovered last time based on the PowerShell commands, right? There was an archive that was created based on the documents folder and all the tag and all the files in there, which was named 1.zip. And that was no evidence of the 1.zip anymore because it was actually deleted afterwards. Now, that's why it might not be in the MFT anymore, but also there's another location such as the USN journal we can look into. And if I type in 1.zip, now I'm getting the journal. So basically the records of file operations that were applied on this particular file that doesn't exist on my system anymore. It's just a log of it. So I can see the timestamps. So it was downloaded at 23:10. And then the last one here was 23:13. And then we can see the operations that happened. We can see it first was created, then it was created, it was overwritten, so the content was basically written to it. And then like 3 minutes later, based on the timestamp before, there was a file deletion operation. That means the file was deleted. That's evidence of a file that was deleted that we wouldn't have seen otherwise anymore. And if I just go now potentially and filter by this timestamp, I could see if there's any other files that might have been created or deleted at the same time that are not on the system anymore. So lots of good stuff, right? And if we put this all together, there's a lot of more artifacts that I would look into, and this is probably some work that you would have that would take a few hours to get into this. I'm just giving you the 1 hour, 2 hour rundown here. If you have more questions, let me know. Obviously, we can do Q&As later, but this is the basics of Windows forensics and everything that we're covering in the practical Windows forensics course. Those are the main artifacts and the main ways of how to go about it. Now, once we put everything together, remember my timeline, if I can find it. This is information we captured about the particular system. Now, I've mentioned a lot of times, right? I would put this timestamp and this kind of artifact into my timeline to keep track of it. And here's my timeline. This is just from disk analysis. Now, I have started, here's the time, here's the host name, client 2, this is the only system we have. Here's my user, the user associated with the artifact that I'm looking at. Here's the artifact. So this is the system hive, NT-user hive, user class hive, MFT, Windows event log. Here's the details. So in my user class, I was looking into shellbacks. In the system, I was looking into the background activity moderator. There's event IDs where applicable. And then there's some details, just basically what it is, right? And so here I captured the files backup folder was accessed. Not necessarily malicious, but for context important, right? I can see Firefox was executed here by Alice. I can see Wireshark was executed here for me to keep track of the PCAP. I can see there was the last time Firefox was executed through a link file. I can see browsing history, which we haven't covered yet. This was the URL that was browsed to at this particular time. So all sorted by time in chronological order. Then we had a file creation of update.exe.hda zone identifier with the zone identifier information. And then we have a sysmon that was keeping track of this file creation event, update.exe.hda. Then we have USN journal, the entries we just looked at right now of update.exe when it was created and stored. Then I extracted shellbacks and saw Alice navigated to the downloads folder. Then I can see MS-HDA was executed, which is basically was run because we double-clicked on the HDA file. Then I put a couple of event logs in there for context, right? A minute later, actually 10 seconds later, we see PowerShell executing to connect to this particular IP address. And if you look into the payload, it's basically establishing command and control there. 2 minutes later, we have a run key that was created with updater that is executing this weird stuff that we've seen before in this weird random registry location. 2 minutes later, we can see invoke environment bypass, a script block. So PowerShell script block logging. I always mention how important that is. Captured a script that was already called invoke environment bypass. So clearly a privilege escalation or some bypassing. And then there was some execution that was captured in PowerShell event logs, by Sysmon event logs done by PowerShell. There was a scheduled task created that we got from Sysmon, but also the scheduled task was called updater, and we also have it actually recovered from different locations, right? If we don't have event logs, there's the tasks/updater file that was created for the scheduled task, and we have task cache in Software Hive that we looked at just earlier that was also created. Then we have, let's go down here, a temp folder that was being created based on the USN journal, because that actually, otherwise we wouldn't know. We then have the 1.zip file that was created, which is our data exfiltrated file for data exfiltration and staging. And then it was deleted right here. And then the case closed because everything that came after was me or the SOC analyst triaging, starting to get on there, right? Capturing the traffic, running FTK imager, creating those memory and page files. So this is my quick timeline that I create out of what we have captured here. Does that make sense? Has anybody seen similar things, done similar things or anything? People like it? Okay. Yeah, so this is kind of how manual timeline creation works. This is a template that I did not come up with. This is best practice still in most firms. A lot of enterprise consultant agent organizations are still using spreadsheets to capture all the artifacts, because that's actually what now I can use in order to put it into a report, right? Or in order to put it into writing. And what is even better, if we have multiple of these systems, for example, I'm looking into one, a colleague is looking into another one, into another disk image, we would then be able to merge those timelines and then see exactly what happened, when, where, and how. And if you have lateral movement in an environment with like a dozen compromised hosts, this timeline becomes really cool, really exciting. So you can see what is going on at particular times in chronological order. So that's basically the incident timeline and how we would create that. And it was only based on manual analysis, but manual disk analysis. So you could put in memory information, disk information, Splunk log data, timeline, whatever you got the information from could be all part of this, obviously. Especially email logs, things along those lines.